All right, so if we take a quick look at that worksheet there that's beneath your notes, just some quick practice to check and make sure that we can understand how to interpret those nucleotide symbols and what they mean. As you take a look at the first example there, we've got an isotope of the element hydrogen. Again, remember that the number on top is going to indicate the mass number, and the number on the bottom is going to indicate your atomic number. Keep in mind that the mass number is the sum of your protons and your neutrons. The atomic number is just the number of protons. So as we work through this worksheet here very quickly, atomic number 1, again indicated by the number that's on the bottom of that nucleotide symbol. Therefore, the number of protons is also 1. We can determine the number of neutrons by subtracting the atomic number from the mass number. In this case, in an isotope of hydrogen 1, we are not going to have any neutrons. In an electrically neutral atom, which is all we're going to concern ourselves with at this point, the number of electrons will match the number of protons. Again, in an electrically neutral atom, you've got to have the same number of positive charges or protons as you do negative charges or electrons. And then our mass number, again, is going to come from the top. In this case, the only thing contributing to our mass is that one proton. As you look at the second isotope of hydrogen that we have to work with here, we are going to notice that the atomic number is going to be the same. All atoms of hydrogen, regardless of their mass, will have an atomic number of 1, which means they've got one proton. This is a heavier isotope of hydrogen. It will have one neutron. It will have the same number of electrons because it has the same number of protons, and then its mass number is going to be 2, this time contributed from the one neutron and the one proton, and we can identify that simply by looking at the number above the symbol in the nucleide notation. Woo! Let's do a couple more because this is super exciting. As you take a quick look at, let's skip down and do one of the chlorine isotopes. Let's do chlorine 35. As you take a quick look at this, our atomic number is going to be 17. Again, coming from that number on the bottom. You could also check the magical periodic table of the elements, which will have atomic numbers for all of the elements. The number of protons then will also be 17. Our number of neutrons, again, we're going to determine that from subtracting the atomic number from the mass number. Our number of electrons in an electrically neutral atom will match our number of protons. And then our mass number will be the sum of our protons and neutrons. Or we can just take a peek there at the very top, 35. All right, and then just a quick look here at things that may be a little more difficult for you. We're not given the nucleide symbol, but we're just given some information about that nucleide, and we're asked to determine sort of what that isotope is. And so as you take a quick look at what we are provided, we're given the number of protons, and we know the number of protons will be the same as our atomic number. And we're also given the mass number, and you should be able to figure out very quickly here the number of neutrons simply by subtracting the number of protons, or your atomic number, from that mass number to get 36. And then our number of electrons in an electrically neutral atom is going to be 30 to match our number of protons. And so as we think about writing our nucleide symbol here, we've got 30 on the bottom, we've got 66 on the top, and then how are we going to figure out what our symbol is? Well, if we go to our periodic table, the element that has atomic number 30 is going to be the element zinc. Therefore, the symbol that we're going to use is the symbol for zinc, or Zn. It's a thriller.